We're finding x bar, y bar relative to the given coordinate system. This piece is kind of obvious here because it's a triangle down. So we have a couple options. We could say take the whole rectangle and then subtract out this piece of the triangle. But I would probably say it's easier if we, let me have it match my notes here. I'd call this shape number 1 is going to be this triangle. If we look at the rest of the shape, what else can we break this up into? Right, I would say this rectangle so what I'm doing with this rectangle is I am including right now a piece of it that's cut out. I'll have to come back and cut that out in a minute, but I'm calling this entire positive space shape number 2. Right, so here we have a semicircle. Again, a solid semicircle. I'll call shape number 3. So this does not respect the cutout at the moment. It's a solid half circle. And then to compensate for including this area and this area, I'll make a fourth shape that's a cutout that's going to be a full circle. So I can do this in 3 positive shapes and 1 negative shape. Again, this is not a unique way to do it, but I think this is probably the easiest way to do it. So I'm counting for only the area in total, because in shape number 2, again, I'm counting the area that's cut out. In shape 3, I'm counting the area that's cut out. But in shape number 4, I remove that area that I included in shape 2 and 3. So in the end, the net effect is the same. It took 4 shapes to do this, and then we'll have our summation. So we'll start with shape number 1. I usually like to do all the areas, then all the x tildes, all the y tildes, but it's up to you. The order doesn't really matter in the end. For shape number 1, I have a rectangle that has a base of 3 and it has a height of 3. So it's 3 times 3 over 2 to find its area, so 4.5 for shape number 1. Shape 2, I have a rectangle, 3 feet. By also 3 feet, so it actually is a square in this case. So that's going to be an area of 9. Shape 3 is this semicircle. From the drawing, the semicircle has a radius of 1.5 feet. The area of a semicircle is half of that of a circle. For a circle, pi r squared is our area. So for a semicircle, we just have to divide that by 2, or multiply it by 1/2. So it's going to be pi times 1.5 squared times 1/2. So for the positive shape 3, that semicircle, that half circle, I'm going to get 3.53. And finally, shape 4 is this full circle, but I'm cutting it out of my shape. So for shape 4, I'm going to count that as a negative area. And shape 4 is a full circle, so its area is pi r squared. It has a radius of 1 foot. So pi times 1 squared is just going to give me pi. And I'll round that to 3.14. Again, it's a negative value. I can now find the area of the entire shape by adding all these values together, keeping in mind that shape number 4 is negative. So 4.5 plus 9 plus 3.53 minus 3.14, 13.9 square feet is the total area of the shaded red shape. Now for the x tilde, so how far to the right or left of the origin, which is here for this shape, for my various 1, 2, 3, and 4. For shape 1, I have a right triangle, and I know from before that its location for its centroid is 1/3 of its base away from the right angle. So because its base here is 3, this is 1 foot. Once again, though, I have to measure from the origin. So to get from the origin to the centroid for shape number 1, I have to go the 3 feet across my shape 2, and then another 1 foot to get to the centroid for my triangle. So for shape 1, its x tilde is 4 feet. Might as well do the y tilde for shape 1 also. its height is 3 feet. The centroid is located a third of its height away from the right angle, so that's 1 foot above the right angle. Because its base is on the x-axis, I just have to go up 1 foot from where the origin is to get to that centroid. So my y tilde is going to be positive 1 for shape number 1. For shape 2, its centroid is at half of its base and half of its height. Its base is 3. From the origin, I have to go over 1.5 feet to the right. For its y centroid, it's 1.5 feet above its base, but again, its base is on the x-axis. So from the origin, I just have to go up 1.5 feet. So positive 1.5. For shape 4, this one's just going to be a little bit trickier. Its centroid is located generally or generically there, but this distance from those charts is 4r over 3 pi, as measured from the diameter or the flat side of the semicircle. So as measured from this line to the left, it's going to be 4 times 1.5 divided by 3 pi. And to get there, I'll have to go to the left of the origin. So this value will be negative for shape 3. My 4 times 1.5 over 3 pi, I'm going to get negative 0.637. And the centroid is always located on the other diameter. So to go from the origin to the centroid of the semicircle, I'm going to go up by its radius, 1.5 feet. So finally, shape number 4, where is its centroid is located just at the center of the circle. Because its center lies on the y-axis, its x tilde is going to be 0. But the center of this circle is located 1.5 feet above the origin, so its y tilde, I get a positive 1.5. And then for the x tilde, y tilde columns, there's no summation there. All the hard work is done. Now the rest of it is just crunching numbers that are already on my table. For my ax tilde, I just, for each row, calculate its area times its x tilde. So 4.5 times 4, I get 18. The 9 times 1.5, I get 13.5. I get here 3.53 times negative 0.637 gives me a negative 2.3. You want to be careful on this step. Areas can be positive or negative, x tildes can be positive or negative, and y tildes can be positive or negative. So make sure you're carrying through the correct signs from your multiplication. I have a positive area times a negative x tilde gives me a negative ax tilde. Negative 3.14 times 0 is just going to be 0. So again, with respect to sign, I add all of this up together, and I get 29.2 as my sum of my ax tilde values. Same thing in the y. Area times my y will give me 4.5. 9 times 1.5 gives me 13.5. Positive area, but now my y tilde is positive, gives me a 5.3 about, positive 5.3. And here I have a negative area, but a positive y tilde. So I get a negative value here, 4.7. Now I sum down this column, and I get 18.6 for my total. Now the last step is finding x bar, y bar. That's just going to be this summation, the 29.2, so the sum of my ax tildes, over the sum of my areas. So I get x bar 2.11 feet. And y bar, I just use the 18.6 over that 13.9. My y bar, I get 1.34 feet. So if I look at my picture, it's not drawn to scale, but I can still see a rough idea. From the origin, I have to go to the right by 2.11 feet, so somewhere around here we'll call it. And then up 1.34 feet, so not quite at the midway point. So somewhere about there for this figure is where the centroid is going to be located.